Hello viewers, welcome to the Advances in Agriculture Engineering course under Annual Refresher Program in Teaching ARPIT. In the past 3 modules, we have covered the agricultural mechanization in the country, agricultural mechanization in the Asia and Pacific region, where we have discussed a number of issues related to the agricultural mechanization, its situation, current trend and the future scenarios. Now, in this module, let us start discussing on the agricultural systems and the sustainability. We shall be covering in this module the sustainable development goals, multifunctional role of agriculture, water, food, energy nexus in specific context of the environment and the innovation led sustainable development. Here are some of the references I would recommend, including the book, some journals. Let us begin with the Sustainable Development Goal or SDGs. The SDGs are a collection of 17 global goals. They are put together as a blueprint to achieve a better and more sustainable future for all. These SDGs were adopted in 2015 by the United Nations General Assembly and they intended to be achieved by the end of year 2030. There are 17 goals to put together. They describe a big picture of the sustainable development in the world. The first SDG is no poverty, zero hunger, good health and well-being, quality education, gender equality, clean water and sanitation, affordable and clean energy, decent work and economic growth, industry, innovation and infrastructure, reduced inequalities, sustainable cities and communities, responsible consumption and production, climate action, life below water, life on land, peace, justice and strong institutions, and finally, the 17th is the partnerships for the goals. These sustainable development goals are required to be achieved by the end of year 2030, but as of now we are able to see that the world where we are living in is quite heterogeneous and obviously one size does not fit all is applicable to this world. Let us refresh our understanding on the existing mechanization with the qualitative summary, and these are the countries which are listed in the first column is Bangladesh, Cambodia, China, DPRK, India, Indonesia, Laos, Malaysia, Myanmar, Nepal, Pakistan, Philippines, Papua New Guinea, Republic of Korea, Sri Lanka, Thailand, Timor-Leste, Vietnam and Japan. These are some of the countries in the Asia Pacific region we will be dealing with in terms of the qualitative summary for their existing level of mechanization. Next column is for the tractor use intensity, which is expressed in the units per 1000 hectare of arable land. We can clearly notice that the countries like Laos PDR, Timor-Leste, they are having very low tractor use intensity, whereby the countries like Malaysia, Bangladesh, India and Vietnam, they are having moderate level of tractor use intensity, whereas China, ROK and Thailand, they are considered to be having high level of tractor use intensities. Similarly, if we will talk about the harvesters and thresher use intensity in terms of units per 1000 hectare of arable land, we can notice that there are countries which are having very low intensity, that includes Sri Lanka. There are countries which are having moderate level of intensity for harvesters and thresher uses, that includes Philippines, China, Indonesia and Malaysia, whereas the countries like Nepal, Papua New Guinea and Vietnam, they score high levels of intensities in terms of harvesters and thresher uses. Then if we will put together another information on the cereal yield expressed as the kg per hectare, we have countries like Cambodia, India, Pakistan and Thailand, which are having low cereal yield relatively as compared to these countries in the Asia Pacific region, whereas countries like China, ROK and Vietnam, they record very high levels of cereal yield in kg per hectare. Continuing this qualitative summary for crop production index, we have very high crop production index in reference to 2004 to 2006 values taken as the reference for Lao PDR. For Cambodia, they are recording very high values of crop production index. For electricity consumption in agriculture expressed as the kilowatt hour per hectare of arable land, we have high levels of electricity consumption that includes China, India, Pakistan, and we have low level of electricity consumption for the countries like Thailand, Nepal, Lao PDR and Indonesia. The agricultural value added expressed as the percent of the GDP, we have very high contribution from agriculture, which is coming from Cambodia, Myanmar, Nepal, whereas very low level of agriculture value added as proportion of the total GDP is coming from ROK, the percent irrigated area of the total arable land, which is very low in case of Cambodia and it is very high in case of Pakistan. Then after this, if we talk about the push pull factors or the drivers of mechanization, the same qualitative summarization can be made in terms of very low, low, moderate, high or very high. That includes the agricultural economically active population to the ratio of total economically active population. Next column talks about the arable land per agricultural economically active population in terms of hectare. Then the last column talks about the arable land use as proportion of the country's total land area. Then if we talk about the sustainability of agriculture, considering both the positive as well as the negative impacts of agrarian activities, then we have indicators including the all greenhouse gas agricultural sector emissions, which is expressed as the CO2 equivalent ton per hectare of arable land or ton per hectare. Another indicator of sustainability which we could use is the fertilizer consumption expressed as the kg per hectare of the arable land. And the final indicator that we would be interested to use is annual freshwater withdrawal in agriculture expressed as the percent of total freshwater withdrawal. We can see that these countries which we have selected for comparison in the Asia and Pacific region, they stand very differently among all these indicators that we have talked about. Let us start revisiting the agriculture in terms of sustainability. The very well known discussion on sustainability is the three spheres of sustainability. Sustainability by definition is defined as the activity or action which focuses on meeting the needs of the present without compromising the ability of future generation to meet their needs. This concept of sustainability is composed of three important pillars. These pillars are economic, environmental and society or social. They are informally also known as the profit, planet and the people. So, if we consider the planet as a true representation of environment, profit as a representation of economics, people as a representation of society, then these three spheres they intersect each other, and the intersection of the all three spheres is the space where we can expect the sustainability. Let us talk one by one for each of these three pillars and their intersection with the neighboring sphere. Starting with the environment or planet, it includes the natural resources use, environmental management, pollution prevention, which include air, water, land and waste. The economic dimension of the sustainability includes profit, cost savings, economic growth, research and development. Whereas the people sphere of the sustainability include the standard of living, education, community and equal opportunity. Now, very interestingly, the intersection of these two spheres, environment and economics, they lead to a discussion on environmental economics, which includes the energy efficiency, subsidies or other incentives which are provided for the use of natural resources. The intersection of the society and economics spheres lead to the business ethics, fair trade and the workers' right. The intersection of society and environment spheres provides us the environmental justice, natural resources stewardship both locally and globally. So, we have got three P's representing environment, economics and society as planet, profit and people respectively. One of the definitions of sustainable agriculture includes the sustainable agriculture is a farming in sustainable ways, which means meeting the society's food and textile present needs without compromising the ability of future generations to meet their needs. Agriculture practices in connection to the discussion of agriculture sustainability is a hierarchical process. How these hierarchies are connected to each other? We may start our discussion with the conventional agriculture, which we all understand that it is resource intensive, it is done in a conventional or in a traditional way. The next block of the hierarchy is the good agricultural practices. So, in this good agricultural practices or GAPs, we follow the principles of GAPs, which in a way better than the conventional agriculture if the environmental dimension is also considered. The next in the hierarchy of agricultural practices is the sustainable agriculture or conservation agriculture, which banks on the principles of zero tillage or minimum tillage agriculture. The benefits achieved from the sustainable or conservation agriculture are no doubt better than the good agricultural practices, and thereby they are better than the conventional agriculture when there is a direction, when there is a discussion on environment. Finally, there is a near organic or organic agriculture, which absolutely talks about the care of environment, care of the nature. So, if we say from left to right, the degree of responsibility in agriculture towards the reduced environmental impact is increasing. So, on the ladder of agriculture, on the yardstick of agriculture, we may say that from left to right, the consideration has been increasing. We are becoming more and more responsible agricultural practitioners if we move our practices from left to right. We may easily talk about the greening of agriculture, the greening of our efforts for the food production. but how much green we would like to be happy with is subjective. As we have seen from the previous slides that in the Asia Pacific region or even in the world, different countries have got different levels of mechanization currently. It may not be wise, for example, to raise simply an animal drawn agricultural activities to the drone or satellite specific agricultural interventions. We may choose our operating point depending on the principles of sustainability that is governed by the three spheres of sustainability, which are once again the people, planet and the profit. So, wherever the three spheres are intersecting each other, that will be determined as the sustainability operating zone for a given ecosystem, for a given locality, for a given set of input output relationships. Agriculture has multifunctional role when there is a discussion on the sustainability. The inescapable interconnectedness of agriculture, different roles and functions are presented in these three once again spheres of sustainability. Now, we are making our focus on the food production as the center of intersection of these three spheres, which is the sustainable operating region of food production. Let us begin with the people side or the social side. We can talk about the health, gender, we can talk about the tradition, society or culture. Then the environmental sphere might include the soils, water, climate, biodiversity. In one of the modules, earlier modules, we have talked about the different types of soils, we have talked about the water and biodiversity. The third sphere, which is the economic sphere, it may encompass the issues related to the income, marketing and trade. Now, let us start discussing the intersection between economics and social spheres, which includes the cultivation and commercialization of traditional food, for example. Similarly, the intersection between the spheres of society and environment talks about the recognition of traditional and diversified land use, whereas the intersection of environment and economics sphere talks about the valuation of environmental services, and the center of these three spheres is obviously the food production in question. Water, food and energy are interconnected, and that is what is known as the nexus of sustainability. These three ingredients, water, food and energy, they are considered under the sphere of environment, which encompasses the three of them. These spheres of water, food and energy, they are supposedly interacting with each other. They both are givers and takers to each other. At the same time, they are corresponding to the environment or ambience surrounding them. Let us try to understand their nexus or relationship one by one. Food is related to water in terms of virtual water trade. For instance, if a country exports X tons of rice to country B, it is not only the quantity of rice, but also country A has transported or traded all the water which was required to produce the X tons of rice is also being traded. So, this may be considered as the virtual water trade. Water is related to energy. Of course, we have hydropower or other such similar water to energy extraction units. Now, food is related to energy. We may utilize some of the energy crops, we may utilize the biofuels, we may also utilize the biomass. So, that is where the food is related to energy in these terms. In vice versa, water is utilized in terms of irrigation and food processing, and that is how water is related to the food. Now, energy is related to water because we require energy to pump the water. This may be the pressurized irrigation. This may also be used as a desalination in the areas, some of the areas of the world. Now, energy utilization for the food production is enormous. It may be used as land preparation. Energy may be utilized for crop production, for crop protection, harvesting, post harvesting, processing, storage and transportation. So, this is a partial list which relates the energy with food. So, if we may drop out from our system of interaction the red arrows linkages, then we are able to focus more on the food perspective by considering this relationship. Water is required in terms of irrigation and food processing for the food, energy is required for pumping the water, and energy is utilized for the crop production in a number of ways which are listed here. And these all three blocks, water, food and energy, they are not only related internally, but at the same time they are corresponding to the existing or ambient environment. The discussion on sustainability is incomplete without the mention of the resource use efficiencies. A farming system is considered to be more sustainable if it operates with greater farming efficiency, while maintaining ecosystem services and improving resilience to the climate extremes. We may talk about different efficiencies, for instance, labor efficiency, water efficiency, machinery use efficiency, fertilizer or nutrient efficiencies and any other chemical. These efficiencies may be expressed per unit of these input use, and in return the crop production. In the cropping system, it improves, it saves farmers operating costs and leads to the reduced environmental impacts. The resource use efficiencies or RUE discussion is very interestingly done in context of the stressors. There are several stressors which stresses or which pressurizes this nexus of water, food and energy. They may be limited land availability, there may be demography, that may be both in terms of the decreased proportion of population working in agriculture, or this may even be the decreased proportion of cultivators as a part of the total agricultural workers. This may be considered in terms of economics, this may be considered in terms of ecosystem and others. So, the energy dimension talks about the production, consumption and energy use efficiency, which once again can be expressed per unit of crop production or per unit of area harvested. Water can be talked about in terms of water quantity, water pollution and water use efficiency. For the food dimension, we may talk about the resource limited yield gap, we may also talk about the sustainable food production, and at the confluence of the three energy, water and food, we have the sustainable agricultural systems or sustainable agricultural practices, and their intersection we have already talked about in the previous slide. From potential yield to the actual farm yield, there is a yield gap, and in order to sustain the increasing population on this earth, any country would like to first check on these yield gaps. In the drive to increase the productivities from the actual to the potential level, the energy, water and food, this nexus, this wheel have to be triggered. While triggering, there will be different types and quantities of inputs utilized, and we can of course talk about the resource use efficiencies, so that this wheel is turned or churned at a speed which can be sustained. There is an innovation led sustainable development. Very interestingly, there are few innovative practices that might include precision agriculture, crop diversification or climate smart agriculture. Now, these innovative practices, they are expected to drive a gear called smart farming. Smart in the sense that the farming system smartly can increase the resource use efficiency. The farming system may smartly choose the operating point or sustainable operating point. The system may increase the profitability to the farmers. The system may talk about the new social farm networks. For instance, this smart farming gear will in turn propagate another larger wheel of sustainability, which of course once again is consisting of environment, economics and social sphere, where we are talking about the reduced environmental impacts, we are talking about the increased income to the farmers or the farming practitioners, and we are talking about strengthening our resilient networks from the social dimension. The sustainable production intensification may include recognition of the need for productive and remunerative agriculture, which will then conserve and enhances the natural resources and the environment. It talks positively about the delivery of environmental services. The sustainable production intensification reduces the emissions and by contributing to carbon sequestration in soil. It enhances biodiversity in crop production systems both above and below ground, and finally, it reduces the impact of climate change on the crop production. So, in conclusion, we may say that the sustainable agricultural mechanization can be achieved by A, sustainable production intensification, B, optimum utilization of farm inputs, and last but not the least, C, the environmental friendly agricultural management. At the confluence of the three, we may expect the sustainable agricultural mechanization. Here are some of the review questions we may expect from this module. We have talked about the SDGs, hierarchy in agricultural practices. We have then discussed the water, food, energy nexus in specific context of environment, the resource use efficiency and innovation as a driver to the sustainable agricultural mechanization. Thank you.